We're going to talk about transformations of exponential functions. In a previous video, what we did is we graphed just regular exponential functions. But notice we have a lot more going on than just b to the x. So things change as we go through here. So in the first statement, it says h is the horizontal shift. So that's going to move you left or right. A plus shifts left and a minus shifts to the right. So basically, it's your exponent that you're looking at. If that exponent is anything other than x, you are going to shift this graph to the left or to the right. Now the k value is the vertical shift. A plus k shifts you up. A negative k shifts you down. Okay? Now, when you have a vertical shift, this changes your range and the asymptote. If you only have a horizontal shift, your range is still at 0, 0, or your range is still greater than 0, and your asymptote is y equals 0. Okay? And we'll talk more about that as we go through these graphs. So if your multiplier is negative, the function is reflected across the x-axis. If your a value is greater than 1, it represents a vertical stretch. And if your a value is between 0 and 1, it represents a vertical compression. So we'll talk about all of these as we go through this lesson. In the first few examples, they're not asking us to graph anything. They're just asking us to identify the parent function and then describe the transformations. So the parent function is just the base and the exponent. So the parent function is f of x equals 3 to the x power. Now, the shift comes when we take that 3 to the x power and we add 5 to it. So this is a vertical shift up. So we're shifting this graph up 5. In our second example, I have an a value, and I also have a different exponent. It's not just x like it was in the first example. So what I need to do first is identify my basics. So 1/4 is my base. So my parent function is the 1/4 to the x power. The 2 and the minus 1 are transformations. So the 2 tells me that we are going to have, since it's bigger than 1, since my a value is bigger than 1, we're going to have a vertical stretch. And since I have an h value, which is always attached to your exponent, I am going to have a horizontal shift to the right 1 spot. Okay, so this is my vertical compression, or vertical stretch, I apologize, and this is going to shift me to the right 1 spot. And I know that because it says if h is negative, we shift to the right. Now, in example 3, I have my parent graph, which is 4/3 to the x power. And I have 3 transformations. I have a negative, I have a change in my exponent, and I have a +7. So it doesn't matter which one you do first. I have a reflection, that's the negative. around the x-axis. This plus 2 moves us to the left. So a horizontal shift left 2 units. And then the plus 7 is a vertical shift up 7 units. Now, I have all three things going on in example 4. I have a multiplier, I have a change in my exponent, and I have a minus 2. First thing I need to do is identify my parent function, which would be just 5 to the x. That is my base power, so 5 to the x. All right? The 1/2 for the transformations, that's going to be a vertical compression because my a value is between 0 and 1. Okay, 1/2 is between 0 and 1. My exponent change moves me to the right, so that's a horizontal shift right 4 units. And then my minus 2 is a vertical shift down 2 units. All right, so we're going to make these changes to our growths and to our decays. Okay, so in example number 5, it says graph each function and identify the key characteristics. So the first thing I see is my base function is f of x equals 2 to the x, but I have a change in my exponent. So what I'm going to do, this is a growth because my base number is 2, so my graph is still going to grow as it moves from left to right. But when I make my table, I'm going to change my x values according to my exponent. So I'm going to take my exponent, set it equal to 0, and I'm going to solve it. So I'm going to build my table around -5. So I'm going to plug these three numbers in for x, get the corresponding y's. So 2 to the -6 plus 5 is 2 to the -1, which is 1/2. 2 to the -5 plus 5 is 2 to the 0 power, and anything to the 0 power is 1. 2 to the -4 plus 5 is 2 to the first power, which is 2. So I'm going to come all the way over here to -6. 1, 2, 3, 4, 5, -6. I'm going to go up to 1/2. Then -5, +1, and -4, +2. And you can see those graphs growing. Now, I did not shift my graph up or down because up here, I told you if you had a vertical movement, it changes your range and your asymptote. Well, we didn't have vertical movement. We had a horizontal shift to the left 5 places. So what our domain never changes. It's always all real numbers. My range is still all y values bigger than 0. My x-intercept, I don't have it, but I can calculate it simply by putting 0 in the problem. So 2 to the 0 plus 5 gives me 2 to the 5th, and that's 32. So my x-intercept, and I do not expect you to graph 0, 32. I'm sorry. I did that completely backwards. That's the y-intercept. I apologize. To find my x-intercept, I'm going to have to go backwards. So this one's going to be a little bit trickier because to find my x-intercept, I need to plug 0 in for y and figure out what my x is. So that's going to be 0 equals 2. Actually, we're not going to worry about the y-intercept for these because we don't have enough information to calculate those. So we're not going to worry about the y-intercept, but remember your asymptote equals to your range. So we do not cross the x-axis as before. And my graph has shifted to the left like it's supposed to. Now, I will come back on a later date and show you how to, once we solve equations, this is a concept that we are not ready for, but I promise you we will come back and hit that particular topic when we start solving logarithmic and exponential equations in a few lessons. So in example number 6, my base number is between 0 and 1, so this is going to be a decay. And I know my base number is 1/3. Now notice my exponent does not change, but I do have a movement of down 2 spots. So I'm going to build my table. I'm going to grab x, set it equal to 0. So I'm going to build my table around my exponent. And when I set my exponent equal to 0, that's what I get. So now I'm going to plug that in to this equation, and I'm going to figure out what my points are. So 1/3 to the negative 1 minus 2, that gives me 3 minus 2, which is 1. I have 1/3 to the 0 power minus 2, which is 1 minus 2. So that's negative 1. And then I have 1/3 to the first power minus 2, which gives me negative 1 and 2/3. Now, we had a downward movement. That means my range has to be above negative 2, and my asymptote is at negative 2. So my graph will not cross where y is equal to negative 2. My graph will stay above that asymptote. So when I plot my points, negative 1, positive 1, 0, negative 1, and if I go over 1 and down to negative 1 2/3, my graph does decrease, but it closes in on a new asymptote, which is not the x-axis. So the only time your asymptote changes for an exponential graph is when you have a vertical shift. You either move that graph up or you move it down. Now, this is positive infinity, so the positive infinity closes in on negative 2. My negative infinity arrow on the negative side closes in on positive infinity. And we're going to skip the y-intercept, although you can see the y-intercept here. And that would be fun. And I do have to apologize to you because I had in my head x-intercept, not y-intercept. So what we did here by plugging 0 in for x and solving for y was correct. So 0 or 2 to the 0 plus 5, I apologize, would be 2 to the 5th, which would be 32. So my y-intercept would be the point 0, 32. What we do not have the ability to do is find an x-intercept for these problems. On this number 6, I forgot my domain, which is all our numbers. So let's see if we can make it through, or if I can make it through 7 and 8. We're not going to do number 9, but we are going to do 7 and 8, and hopefully that will give you enough to go by. So I have a couple of things going on here. I have a 1/2 and I have a +1. That +1 is going to move me up, which moves my range up, and it moves my vertical asymptote up. So everything I do to this graph is going to stay above that line. Okay, my domain, that's understood to be all real numbers. That does not change. So I'm going to make my table, but first, before I make my table, I'm going to take my exponent, which is x, set it equal to 0. So I am going to build my table around 0. At this point, you're just going to plug those numbers, -1, 0, and 1 into your problem for x and figure out what the corresponding y's are. So 1/2 times 3 to the -1 plus 1. That gives me 1/2 times 1/3 plus 1, which is 1/6 plus 1, which is 1 1/6. I'm going to plug in 0. So 1/2 times 3 to the 0 power plus 1. Anything to the 0 power is a 1. So that's 1/2 times 1 plus 1, which gives me 1/2 plus 1, which is 1 1/2. I'm going to have to erase some of this so I can make room for my last number. So 1/2 times 3 to the first power gives me 1/2. I said 1/2. I got ahead of myself, wrote down my 3. 1/2 times 3 plus 1. 1/2 times 3 is 1.5 plus 1. So I end up with 2.5. So as I graph this, -1, 1 1/6, so I'm above that line. 0, 1 1/2, and then over 1 and up, 2.5. So you can see that graph growing above that y equals 1 line. So your positive infinity, as x approaches positive infinity, y approaches positive infinity.
Attention teachers and staff, we are going to conduct a fire drill.
Sorry, we just had a fire drill, so that was exciting. So where were we? Negative infinity. As x approaches negative infinity, y closes in on that asymptote, so it closes in on 1. You can go here and get your y-intercept out of your table. That would be the point 0, 1 1/2. All right. I did tell you that we were going to do number 8, but we're not going to do number 9. So in this problem, I see 2 movements. Okay. Now, 3 over 2 is bigger than 1, so this is going to be a growth. I noticed that my exponent changed, so x minus 4 equals to 0. So when I go to build my table, I'm going to build my x values around 4. This also drops me down 5 places, and that changes my range to y is greater than -5, and my asymptote is y equals -5. So everything I do, 1, 2, 3, 4, -5, should be above this line. So I'm going to plug my numbers in that I got from my exponent. So that's going to be 3 over 2 to the 3 minus 4 power minus 5. That's going to give me 3 over 2 to the -1 minus 5. 3 over 2 to the -1 becomes 2/3 minus 5. So I end up with -4 and 1/3 when I add 2/3 to -5. Now, clear that out of the way so I can do the last 2 numbers. So 3 over 2 to the 4 minus 4 power minus 5. That gives me 3 over 2 to the 0 power minus 5, which is 1 minus 5, which is -4. And then the last number, we're going to have 3 over 2 to the 5 minus 4 power minus 5. So that is 3 over 2 to the first power minus 5. So that's 1.5 minus 5, which is negative 3.5. So my domain, we can already write that down. So as I graph these, every single point I graph will be above that asymptote. So I'm going to go over to positive 3, 1, 2, 3. I'm going to go down to 4 and 1/3. So that would be 1, 2, 3, 4, and a little bit below that. Positive 4 is at 4. And I've got 5 and 1, 2, 3 and a half. So my graph is going to grow. The reason it is going to grow is because my base number is bigger than 1. Now this is positive infinity. So as x approaches positive infinity, y goes up. As x approaches negative infinity, I'm closing in on negative 5. I do not have my y-intercept listed in my table, but I can add an extra point and use my calculator to get that. So I've got 0 goes in, so 3 over 2 to the 0 minus 4 power minus 5. That's going to give me 3 over 2 to the negative 4 power minus 5, and give me just a second to calculate that. 1.5 to the negative 4 power, and then I'm going to subtract 5, and that gives me roughly negative 4.8. So my x-intercept or y-intercept is the point 0, negative 4.8, roughly. And that should be 0, negative 4.8, and it looks like my graph is going to go through that point. So I hope this helps, and if you have any questions, please make sure that you contact me.